Good afternoon, ladies and gentlemen, and for some of you, good morning, and others of you, good evening. We've got a global audience today, so thank you very much for sparing the time for today's webinar. I'll be recording the webinar, and I'll also send you a link to the recording and a copy of the slides in PDF format in the following days. So today we're going to be looking at the British Rainfall Digital Archive, and I'm delighted to be joined by Harvey Rodda. And Harvey is a director of Hydro-GIS Limited, and he's got over 20 years postgraduate experience in research and consultancy in the public and private sectors in the UK and overseas. What Harvey's going to do is give a little bit of a background to the digital archive, and then talk about how the digitization process, and then finally look at some applications of how you can use the data today. So Harvey graduated in environmental science from Lancaster University and completed a PhD in the Department of Geography at Exeter University in 1993, and the field was hydrological modelling. Harvey's also a fellow of the Royal Geographical Society and a member of the British Hydrological Society, and a chartered water and environmental manager. Harvey started his career in consultancy at NIWA, which is the National Institute for Water and Atmospheric Research Limited in New Zealand, and that was between 1994 and 98. And there he undertook a number of water quality related projects for the dairy and fertiliser industries. It was here where he really first pioneered the application of hydrological models within a GIS framework. When Harvey returned to the UK, he moved from water quality to flood related studies and worked for a range of organisations. And then in September 2004, he founded Hydro-GIS Limited, and he's since continued working on flood-related projects, ranging in scale from developing regional flood models to local studies. Most of the work has been with the private sector, where he's developed countrywide flood catastrophe models for use in the insurance sector, undertaken specialist studies involving hydrological modelling and GIS, and worked on site-specific flood risk and provided expert advice in relation to planning applications. Harvey's also a visiting lecturer at the Department of Earth Sciences at UCL, University College London, and he contributed a module to the Geophysical Hazards Masters and a Natural Hazards for Insurance Certificate course since 2005. Harvey's also a partner of Water Resource Associates, a network of consultants working in water resources and hydrology. So with that introduction, I'd like to hand you over now to Harvey. Thank you.
Okay, good afternoon, Jim. Thanks very much for that, and thank you everyone for joining this webinar. Yes, my presentation today, the title of which is Using Historic Rainfall Data to Improve Forecasting, but it's more general insight into historic rainfall data, particularly for the United Kingdom. So first up, I'm going to talk about the source of this historical rainfall data. And it's come from a publication called British Rainfall. British Rainfall was started in 1860 by a gentleman called George Simons. That's his gather information on rainfall. And it started with observations from just 168 stations, rain gauges, in the British Isles. From this gathering of information, he published this book. It's an annual publication called Simon's British Rainfall. That continued under that name until his death in 1900, but then it was taken on by the Met Office as a Met Office publication, and ran up until 1991 with observations from approximately 6,000 gauges. What did it look like? Well, to start with, it was an A5 type hardback publication, which went through various versions, and then in the 1960s it became A4 size, looked a bit more technical and scientific, and then through the 1970s, the 1990s became a glossy magazine, until it was discontinued largely because by that time all the data was archived electronically. What this publication included? Well, it's really what it says on the cover. It gave a listing of rainfall observations in Great Britain, in fact in the British Isles, I should say, It's included annual totals, monthly totals, days on which rain fell, maximum falls in 24 hours, extreme falls in short periods, information on the lack of rainfall. That would be drought periods, and discussions on trends in rainfall, looking at averages over a number of years. Each edition, like I said, it was an annual publication, also included special sections on the methods of rainfall measurement. If there was a particular extreme event, that often had its own section, and there was information for the observers, information on rules, how to gather rainfall, some information just about the observers who were taking the information. And there were occasionally also sections on evaporation. Obviously, that's what happens. One of the things that happens to rain when it reaches the ground, and also information on rainfall durations. Now, out of this publication, there was a very interesting chapter entitled "Heavy Rainfall on Rainfall Days," or "Heavy Falls in 24 Hours." And what this did was it provided very detailed information on just extreme rainfall events. This included listings of 24-hour observations, so that's the total rainfall collected over the 24-hour period, the standard period being from 9 in the morning till 9 the next morning. It gave listings of all depths that were recorded over a particular threshold. To start with, using the old measurements, that was 2.5 inches, or 7% of the annual total. Then in 1961, the metric system was introduced, and so any depth greater than 50 millimeters was recorded. And also that then changed the threshold for the annual total to greater than 4%. Not only did it include all these depth measurements, but it included descriptions of the event from observers. So these were some of the official observers who took those records for the British rainfall, and sometimes just information from other eyewitnesses. Not just necessarily the information about the rainfall, but also a general summary of the weather conditions, any information on the floods which ensued, and also damage. The publication was supplemented with some very nice and graphic isohydral maps, so maps showing the rainfall contours for a particular event, and a lot of old photographs. And this chapter was included from near the start of the publication in 1866, get the year right, and it ran right through to 1968. Here's an example of some of the data which was included. This is a listing of rainfall observations, rainfall depth measurements, for the 24th and 25th of August in the year 1891. And you can see we have a list of locations. The locations are given a name. They're also given a division. That was during the early part of the publication. There wasn't really accurate spatial information for the location of gauges, so they were grouped together in divisions. But then you can see the rainfall listed for those days and the total in 48 hours, and that's given in inches. So obviously inches, the old-fashioned measurement, but that's the simple conversion is to multiply everything by 25 to get it into millimeters. So when we're talking about a rainfall of 4 inches in 24 hours, that's 100 millimeters. Here's an example of the type of text which was included in this publication from January 1927, which gave quite a graphic description of the weather and the rainfall, including gales and other information. And then here's an example of the sort of isohydral map that was produced. This was drafted by the editor, so by Simons himself, and then the editors who succeeded him, drafted by draftsmen from instruction from the editor, and they produced incredibly detailed and well, very, very pretty isohydral maps giving the scale of rainfall in well, in this case, in divisions of half an inch. And occasionally you also got photographs, particularly when there was some flooding and something interesting that happened. So here's an example of some of the flood damage, collapsed wall and flooded street, and well, street that was to have had its surface ripped up in the Rodda Valley back in 1929. And what was particularly interesting about this publication was that it was all done through correspondence by mail. So you had the editor, Simons, and his successors, and they had a few, maybe 3 or 4 people helping in an office in a house in London, and then you had this network of rainfall observers throughout the country, and that grew rapidly to many thousands. And the correspondence between the editor and the observers was a key component of producing these publications. And one of the things that I was particularly impressed with when I was gathering the data was the degree to which quality control was included, so that there was this correspondence between the editor and the observers. Any unlikely depth observations were compared with observations from nearby gauges. Observations were also noted when gauges overflowed, and if there was a spurious value which couldn't be supported by other evidence, then averages were taken from surrounding gauges to replace that. Here's an example just at the bottom where there may have been what was an unusual measurement at one gauge, but the publication stated, "Nor does a shadow of suspicion rest upon the record. The gauge is a good one, the observations have always been carefully made, and the above figures are thoroughly supported by the surrounding stations." So quality control was very important. Just in terms of an overview of the observations, to start with, obviously with a sparser network of gauges, there weren't that many entries per year, but as you got through to the early 20th century, this grew towards 500 observations. And what was interesting was that the year that it finished, in 1968, you had over 2,000 observations. I always wondered if that was the reason why they stopped including this chapter, and that after having to type in these 2,000 odd observations, everybody got fed up. I found out later it wasn't, but it's an interesting side issue. What you should note as well is that the number of rain gauges that were used to provide this information in British rainfall far exceeded the number of gauges for which you can get digital data from the Met Office. The Met Office has very complete digital records back to 1961. Then since then, or so not since, as in going back further in time, it tails off. Whereas British rainfall, even at the turn of the 20th century, they had information from around 4,000 rain gauges. So it's a much more complete record of extreme rainfall than is available from digitised information from the Met Office.
Harvey, thanks for the background on that. I just wanted to, first of all, some of I love the language with vigorous secondaries as a description, and the maps are a thing of beauty. Before you explain about how this was made into a usable digital archive, I just wanted to let people know, if they've got any questions, there will be time for questions at the end. So if you've got any questions, just type them into the Q&A box. If you move your mouse to the bottom of the screen, it should pop up and allow you to enter questions in there, and we'll have time at the end to answer any questions. I'm also recording the webinar, and I will send you a link to the recording and a copy of the slides in PDF format in a day or so's time. So sorry to interrupt, Harvey, back to you.
That's perfectly all right. Okay, so that's the summary of the historical information that was used to create the archive. And the archive itself, the digital archive, well, that was generated as part of a Natural Environment Research Council funded research project between Hydro-GIS and Oxford University, which ran over the period 2007 to 2009. The title of the grant which was awarded was called Quantifying Flood Risk of Extreme Events Using Density Forecasts Based on a New Digital Archive and Weather Ensemble Predictions. My company was involved chiefly with compiling this archive in a digital format and a usable format, from which the colleagues at Oxford University undertook some more detailed research, particularly on the mathematical side. So all the tables of depth measurement, all the text in these publications of eyewitness accounts, all the maps and photos were converted to digital format. So ultimately that included about 28,000 observations of extreme rainfall, over 1,000 pages of text, and 250 maps and photographs. And as part of the study, this was undertaken by simply digitizing, so scanning maps, scanning photos, scanning text, making it into MS Word using text recognition software, or Excel for the tables of rainfall observations, so to make those usable. And as I mentioned, this was initially used for research into extreme rainfall events, and what the people at Oxford did was particularly look at the application of database mechanistic modelling and machine learning, and there are a couple of publications which have resulted from this study. Now, the data that was actually made available through Hydro-GIS up until 2018. We had a GIS-based search facility, but what's been happening currently over the course of this year is that data has been reformatted, and it's available now through different formats and being available on the Oasis hub. How that data has been reformatted just recently, in that with the original digital archive, we just had the scanned isohydral maps as JPEG images. What we then did was we converted those into a grid format, into a usable format. So the maps have been georeferenced, the isohyets, the contours have been digitized as polylines, and then interpolated surfaces have been generated using a 5-kilometer grid resolution using the topo to raster tool from ArcGIS Spatial Analyst. And that's been saved as an ASCII grid format so that it can be used in different GIS software. And there's just a schematic showing how that goes from the original scanned image on the left of the screen through to georeferencing that, through to producing the isohyets, and then producing a grid. And obviously the beauty of that grid data is it's no longer an image, it's a raster file, so it has the data behind it. And overall, we've converted 228 maps into a gridded format, gridded footprints, as I like to call them, covering the British Isles. Unfortunately, 26 maps weren't gridded. Either they were a detail of an existing map, so it wasn't actually anything that would add to the data set, or they didn't have sufficient information for accurate georeferencing, because that was something that was obviously required. And 6 offence, which were just affecting the island of Ireland, were excluded because they did not use the Ordnance Survey grid of Great Britain. What I should say, because obviously this publication was started back in 1860 when the Republic of Ireland wasn't a country, it was part of the British Empire. So up until 1939, the events also include events that affected the Republic of Ireland.
Thanks, Harvey. I mean, one of the questions that springs to mind is, we're looking at historical data. So, what can you use historical data for today in a kind of, in the current world?
Well, that's going to be my next section, actually, Jim. So I'm now going to move on and talk about the potential uses of the British Rainfall Archive. And it has a wide range of research applications to start with in meteorology, climatology, hydrology, even other fields. Certainly in the area of catastrophe modelling, which is something that many of the listeners or attendees, or you like to call them, would be involved in. So yes, it has applications for studies of extreme weather, particularly helping to estimate a design rainfall. If you're doing a flood study or a drainage study, often you need to design a measure, a feature on the ground to accommodate the volume of water that will be produced by a rainfall of a particular probability, like a 1 in 100 year rainfall. It can also be used for looking at long-term climatic trends. Not many places have data going back 150 odd years. It can be used to assist with flood studies and drainage design, as I've said. Certainly the spatial element of the data, that we've got a large number of rainfall footprints, those can be used directly as scenarios to assist with flood forecasting and emergency management, and also used as as event data for catastrophe model validation. I'm going to go through some of these now. Part of the work for the initial study was to actually classify these rainfall events that affected the British Isles, and based on the patterns from the rainfall footprints, based on the intensity, how much rainfall there was, and based on the seasonality, we came up with a classification of 5 different types: mesoscale convective complexes, east coast, thunderstorms, orographic, and depressions. And there's a description of each of these. Mesoscale convective complexes is a name given by meteorologists to very heavy rainfall events, so small depressions which are characterized by intense precipitation from convective cells within a larger area of continuous rain. And those have been responsible for some of the most severe rainfall events in the UK, and most severe flood events, particularly flash flood events, often affect the south and southwest of Britain. East coast events, as the name suggests, are events which affect the east of the country. Those of you familiar with the rainfall of the British Isles would know that the maximum or the highest areas, the wetter areas, those that have a higher standard annual average rainfall, are in the mountains, chiefly to the west. What happens with an east coast event is you get, just for a single event, you get the reverse of that pattern, where the depression would store as it moves across the British Isles, and then it would bring rain-bearing winds from the east off the North Sea to affect coastal areas on the east. Thunderstorms, obviously, we'll be familiar with thunderstorms. Those were classified differently as mesoscale convective complexes in that they tended to be more isolated occurrences of convective cells, so they didn't have the larger depression structure of an MCC. Orographic events, those were the events that were associated with the more normal west to east movement of Atlantic depressions over the country, and rainfall being enhanced in those higher areas, chiefly to the west. And then where we couldn't find any other particular features, but we knew that there was a depression involved from information in the eyewitness accounts, then that was attributed to a depression. So got just some pictures of those in terms of the isohydral maps, and these are the copies of the isohydral maps from British rainfall. So you can see an MCC affecting the southwest to the left there, and then on the right you can see an east coast event where you have a pattern of the most intense rainfall moving out from East Anglia further west. Then a thunderstorm, which is obviously occupying a much smaller area, and you can see within that there's a structure of maybe 2 sort of swathes of rainfall, as you would get the movement of a thundercloud, the movement of a couple of thunderclouds in seems to be southwest northeast direction. Then for the other 2 events, we've got an example of an orographic event where the high ground in the Lake District and Snowdonia receives the most rainfall. And then finally, an event where there appears to be some movement of a front or a depression across the country, but generally there isn't any characteristic feature that we can attribute that to one of the other event classes. Just information now on the actual observations of rainfall from this archive. When we put everything together and totted up the observations over the full record from 1866 to 1968, those are plotted in the figure you see in front of you, and what it gave was that the average maximum for any one year was 149.8 millimeters, with a minimum of just 91.9, but maximum overall of 279.4, which was recorded in 1955. And so what that would say is that a fall of 100 millimeters in 24 hours actually isn't unprecedented. It would be expected somewhere in the British Isles every year. So when you hear on the news that a place has been flooded and that they might have had 100 millimeters and they talk about it being unprecedented, well, that's not right. You would expect, on average, that would occur somewhere every year. When we look at the impact of climate change, which is certainly a very real and valid application of this data set, where we've got the type of distribution of points over the period of record, we can just play around with that and think, well, with climate change, one of the features is that with a warmer atmosphere, the laws of meteorology dictate that that will hold more moisture. Therefore, rainfall totals will be higher. So where you have this existing pattern of extreme rainfalls occurring over a 100-year period, you know, what would happen if you stick in just an increase to account for that climate change? So this hypothetical figure on the screen shows, well, I've labeled it from 2000 to 2100 on the x-axis, but it is just a period of time to represent what could be the impact of climate change. And I've used what the Department for the Food and Rural Affairs in the UK have generally used as an allowance to increase design rainfall by, to incorporate the effects of climate change. So that's a 30% increase. And you can see you start getting years when you're having falls over 250 millimeters, some falls over 300 millimeters in 24 hours. And when we look at what's happened, well, as my colleague from UCL, Bill Maguire, said, there is a grain of truth in that. And I think, well, not in this instance, there's a grain of truth. There's a whole lot of truth in that. Just recently, in the last 10 years, we've had falls where rainfall totals over 200 millimeters have been recorded over the standard 9 a.m. to 9 a.m. period, much more frequent than have been recorded over the last 100 years of the digital archive. So these are some rainfall totals listed from Cumbria, the Lake District, which was subject to severe rainfall in 2009, when you had over 253 millimeters in 24 hours recorded. And then again in 2015, only 6 years later, had even more. And these are the standard periods, which are direct comparison with those from the British Rainfall Archive. But because some of these gauges were recording rain gauges, tipping bucket rain gauges, taking readings every 15 minutes, what the Environment Agency could do was actually cherry pick the most severe 24-hour period, and two gauges, Seathwaite Farm and Honister, actually exceeded 300 millimeters over that sliding 24-hour period.
So there's no such thing as unprecedented anymore.
Is that a question, Jim?
No, I'm just saying it sounds like it. It
Well,
sounds like that. You know,
yes.
use of the word unprecedented is no longer valid, I guess. So yes, so I guess the next question is, as you're covering here, is, you know, the examples of specific extreme rainfalls that lead to that have led to a historic flood event.
Yes, so that's what I'm going to present now. And one of the earlier images showed the rainfall associated with the Lynmouth flood from 15th to 16th of August 1952. And this is probably the most catastrophic flash flood event that's been experienced in recent times in the British Isles. And it was, as you can see with the picture to the right, it was incredibly devastating. There was a lot of damage, and it was caused by a mesoscale convective complex from the Bay of Biscay, brought over 200 millimeters to southwest Britain, and in particular, the maximum observed measurement was 229 millimeters at Longstone Barrow on Exmoor. And as that's a fairly isolated or fairly sparsely populated part of the country, there wasn't a particularly dense gauge coverage, so many observers or scientists have commented that the actual totals could have been higher. Most of the rainfall was concentrated within the drainage basins of two small rivers, the West and East Lynn, and so it all ended up eventually funneling to pretty much the same place, which was the town of Lynmouth. And because of the the steep gradient, certainly steep in UK terms, going from 500 meters above sea level to sea level in 10 kilometers. You had a tremendous flash flood. The streams were full of debris as well, brought huge boulders down, and ultimately caused 34 deaths, 93 houses, 66 vehicles, and 28 bridges were destroyed. What's less well known, however, is flood that affected also an area southwest of the country, with rainfall totals being measured in a place called Martinstown. Now, this was slightly later than Lynmouth, but only 3 years later in 1955. And this is actually the highest recorded 24-hour fall that's available in the archive, and is still the highest recorded fall on record over the 9 a.m. to 9 a.m. period. In this instance, another MCC brought heavy rain to the southwest of the country, and again there was a rain gauge which recorded this, but an unofficial catch in an oil drum on the hills above the village reportedly measured 355 millimeters in 24 hours. It wasn't just the immediate area around Martinstown that was affected, but the heavy rain covered quite a wide area, as far as further west into Devon and further north into Glamorgan in South Wales. And it caused flash flooding in the centre of Weymouth and Dorchester and surrounding villages. Fortunately, there weren't as many deaths as with the Lynmouth event, 2 fatalities, but 600 people were evacuated from homes, and the flood waters rose to 1.3 meters deep, as can be seen in these photos. It's often known as the forgotten flood of Weymouth, because these events, unless they are incredibly catastrophic, tend to be forgotten. So moving a bit slightly more recent in the 20th century, to the 10th of July 1968, and I suppose by contrast to the Lynmouth and the Martinstown events, this was a flood event that affected a large area with extreme rainfall from the Severn estuary right through to the Wash, and caused 7 deaths with an estimated 3,500 buildings damaged, and again numerous bridges destroyed. And rainfall totals were, well, not quite as high as the previous events, but up to 175 millimeters in 24 hours, enough to cause considerable devastation, and again flash flooding. Southwest England was worst affected, with areas of Bristol and Bath being flooded. And in this instance, we've got some colour photos to show you. So, of course, when we talk about historic rainfalls, you think it's way back in the past, everything in black and white. But, well, there was colour film around in 1968 to take pictures of that.
Thanks, Harvey. Just a note to the folks who've asked questions. We have got them, and we'll answer them at the end of the presentation. Thanks.
Okay, so I've just got one final section really, which is looking at some applications of this data. And one of the things that I mentioned earlier was looking at catastrophe model validation. So rainfall footprints and the ensuing floods which are available in this data set, are those adequately represented in catastrophe models? And I know the Risk Management Solutions UK flood model is currently based on a pan-European rainfall event set. Now, does that event set include the sort of events that we've seen occur in historical times? Does it have the well, that's Lynmouth, but there are numerous other events that have affected the country and are available in this archive, affecting the length and breadth of the country, as you can see. So that's one particular use that I can see for this data, an immediate use in the insurance sector. It can also be used in more site-specific type studies. are predicted rainfalls and hence flood discharges from the Flood Estimation Handbook, representative of historical events. Those of you who aren't familiar, the Flood Estimation Handbook is a series of procedures which is the standard approved methodology for estimating floods in the UK. And in this example, I've just put up the main sub-basins of the Thames drainage basin on the screen, and you might have a requirement to build some flood defences in one of these basins, and you would use the Flood Estimation Handbook to estimate initially a design rainfall and then a design flow, and see if that would be actually replicated by the information that we have from the British Rainfall Digital Archive. So, for example, if it was one of these catchments up in the far west that was hit by an event, is the rainfall that you have used from the Flood Estimation Handbook, is that representative of something that we know from a historical event? And as an example, well, just personally a little bit more information about the Flood Estimation Handbook. Their rainfalls are based on the Met Office digital data from 1961 onwards for point observations. It may not capture many of those events that we have from the British Rainfall Digital Archive. So how does their 1 in 100 year rainfall compare with that from an own historical event? Will it be an underestimate, which is obviously a position you don't want to be in, have an under design of your flood defences or flood alleviation scheme? Looking, for example, at the events in the British Rainfall Digital Archive, there are 16 observations over 200 millimetres in 24 hours. Those are included in the table here. The ones I've highlighted in yellow occurred in the county of Somerset, in and around the town of Bruton, and you can see 4 observations from the 28th of June 1917. Now, when I was involved in a study close to Bruton, only about 20 kilometres away, I had to generate a 1 in 100 year rainfall for a drainage design, and the Flood Estimation Handbook gave that as just 44.7 millimetres. So is that a realistic estimate of what 1 in 100 year rainfall is, when we know that back in 100 years ago, at a number of locations, that value exceeded 200 millimetres in 24 hours? Looking at a more recent event, the floods of 2007, which some of you may have experienced firsthand. The summer of 2007 was notably wet across the UK, particularly southern Britain, and there were 2 main flooding episodes, one in June and then one later on in July. The event in June, the 25th of June, caused widespread flooding in northeast England, including the city of Hull, and 103 millimetres in 24 hours was the maximum total that was observed. What was interesting in this instance was that the Environment Agency flood zone maps, which had been already produced at the time and were used for flood warning purposes, many areas outside even not only the high risk but also the medium risk were affected. And this was largely due to the fact that the maps were generated for a small stream that flows through the north of Hull called the Foston Beck. They were based on flow records back to 1958. But what we found out was that the flood risk was underestimated because they didn't actually look at the data that we have in the British Rainfall Digital Archive. They would have done, they would have found that there was an event in 1892 which produced very similar totals of rainfall across the northeast of England, as you can see by the map here, affecting much of the county of Yorkshire, including Hull. And not only the map, but the rainfall, the actual rainfall values show that in a period of 3 days, you're getting up to 150 millimetres, with certainly 3 or 4 observations of over 100 millimeters in one day. So very similar rainfall amounts to what was experienced in 2007. And very interesting that the text that was associated with the event and included in the British Rainfall publication for the year, which I will now read out, because I think that red text on the blue screen isn't particularly clear for you, but it is very difficult without or even with a series of photographs to form any idea of the mischief which this rain produced in the lowlands on the side of the principal rivers. We can give only a few facts and must leave our readers to fill in the details from their own knowledge of the necessary discomfort and danger. It is impossible to state the number of houses flooded. The official report for York alone was more than 500. We have dozens of photographs of or details respecting flooded houses in Barnsley, Batley, Bingley, Boroughbridge, Castleford, Cleckheaton, Dewsbury, Doncaster, Ferrybridge, Halifax, Kirkstall, Nottingham, Leeds, Pateley, Pickering, Selbury and Wakefield. We feel sure that the total number of houses flooded could not have been less than 4,000. So if you think back in 1892, 4,000 houses flooded. In the intervening time between that and the present day, how many more houses would be at risk within that area should this event occur again? So I think certainly the Digital Archive has a very, very relevant use with flood management, particularly in relation to climate change. So that concludes my presentation. Thank you very much for your attention. I do have some questions which I'm going to attempt to answer, but if there are any others, please type them up and I'll see what I can do. So first of all, I've got a question which is relating to the interpolation technique used to convert the isohydral maps into gridded data. This used the topo to raster technique from the Spatial Analyst in ArcGIS. What the actual interpolation is, I guess you would have to go and look at the interpolation routine itself, but it's one of the standard methods used in ArcGIS. So I hope that answers your question. A second question, wanting to know how the rainfall data in the British Rainfall Digital Archive compares to the Met Office records of the same time. Well, perhaps my slide showing the number of gauges used by the Met Office and the number of gauges used by British Rainfall was slightly misleading. The Met Office has digital archives for pretty much all the gauges going back to 1961. Then going back further in time, it has data for selected gauges, but not all of them. British Rainfall, the archive that we have, has data for all of those gauges. The Met Office gauges would be a subset of the British Rainfall gauges. So they should, in effect, have exactly the same readings, assuming that the same degree of quality control has been in place. I say assuming that because when we were doing this study in 2007, my colleagues from Oxford University had access to Met Office data, and they were requesting digital data free of charge. I think as a university you can get it free of charge. As a consultant like myself or a private company, you have to pay a lot of money for it. Anyway, we came across a value that had recorded over 400 millimeters at one point in 24 hours. And I said, well, that can't be right, because anyone in the hydrological community would have heard of that. And then he looked around in more Met Office data and found another very high value. So I was slightly concerned that despite the efforts of quality control that I've presented in the British Rainfall Digital Archive, it appeared that some of that quality control was lacking from the Met Office data, and we were getting incredible values which were present and obviously were not the case. Otherwise, we would have all heard of it. Further question, can you remind me what the threshold was for the selection of the rainfall footprints? Well, the threshold was that any data entered in the original publication, you had to have rainfall depth in 24 hours greater than 63.5 millimeters up until 1961, and then after 1961, anything greater than 50 millimeters. Or it had to be greater than 75% of the annual total for that gauge up until 1962, when it was changed to 4%. So that was the threshold for any data that was actually listed in the publication. But for the rainfall footprints, that was more qualitative, that only a subset of all observations were actually used to produce maps. So I think it was, if there was an interesting event, if it affected a large enough area, or if it was particularly severe, then the editor of British Rainfall decided, oh, it's worth producing a map to describe this event. I don't think there was a particular numeric threshold through which an event was mapped or not. It was generally just the desire of the editor of British Rainfall.
Thank you, Harvey. That was fascinating stuff. Thank you very much, and
So
thank you.
Those are all the questions I've got now, Jim. But obviously, if anyone's got anything else, they can send me an email.
Yes, if there are any questions, please feel free to ask them now. If we don't have time to get an answer to you right now, we will email a response back to you as part of the follow-up. But thanks again, Harvey. That was really fascinating stuff, and thank you to everyone that took part as well. Right, question. A couple of questions that have come in. What I'll do is, Harvey, if you don't mind answering those, and I will switch into show people where they can get access to the database. Okay.
Okay. Yeah. Well, the database is available on the Oasis Hub. We already have the rainfall footprints. All those rainfall footprints as ASCII grid files are available. The other two components of this is that, as I understand, the people at Oasis are working on having an online-based system for selecting data for particular locations. So if you have a particular site of interest and you want some historical data, that was a system that my company offered, but we've now moved that to Oasis. So that should be implemented soon, and then the full archive, which includes all of those 28,000 observations, all of the original rainfall maps, all of the text entries, that is also available. I'm not sure if we've got that mentioned, but it's certainly something that is available through Oasis, and I'd be happy to discuss pricing should anyone be interested. I see we've got some other questions. I think that answers one of them, because one of them is asking what's available. How can we get hold of a copy of the archive? That answers that question. Did we try to couple the precipitation to a hydraulic model? No, that's not something that has been tried yet, but again, it's another application. As I gave the example of how you could use data you could extract data from one of these rainfall footprints to feed into a hydrological model. Obviously, with your hydrological model, you were clever, you could produce flows, you could resample the 24-hour rainfall depth to fit a rainfall profile like you get in the flood estimation handbook, so that then you could use that as an input to the flood estimation handbook revitalized flood hydrograph, which would give you a hydrograph, and then you would have to input that into a hydraulic model such as HECRAS.
Thanks, Harvey. We've got a couple of options for getting access to the data. As Harvey mentioned, we've got an interim step at the moment. So you can view a kind of a summary of the data in the imagery here. If you want to be more specific, then if you click this URL, it will take you into a form where you can actually request specific region. So you can, give us your contact details, and then provide town postcode coordinates that long, and an idea of the radius that you'd like data for. And then what we can do is we'll work with Harvey to kind of get an idea of what that will cost to sort of ring fence that and present that data out to you. So there's a couple of options there for you to work with. Okay, hopefully that's answered all your questions. Thanks again, Harvey. That was really, really fascinating. And thank you everyone for taking the time to attend today. I will send in the next couple of days a copy of the slides in PDF format and a link to the recording as well. And if in the meantime you've got any questions, please feel free to get in touch with me, jim.craig@oasishub.co, or you can email hello@oasishub.co, and we'll get back to you as soon as we can. So thank you everyone, and hope you've enjoyed the webinar, and we look forward to seeing you on another webinar soon. Thanks, and bye for now.